whatever we have done so far in organic chemistry, it's all about the theoretical concept. Nobody have seen inductive effect, nobody have seen resonance happening. But there are proofs for the consequences of this inductive effect and resonance. But anyway, it's a theoretical concept. Whatever we have learned, it is all theoretical. But now on, whatever we are going to learn is called as practical chemistry. It's practical because whatever we discussed from this point onwards in this chapter, everything can be proven in a laboratory. And there are three segments in this practical chemistry. Segment number 1 is purification techniques. Segment number 2 is qualitative analysis. And segment number 3 is quantitative analysis. So what is this purification, qualitative and quantitative analysis, all of this together? And what is the importance of this in chemistry? So when you practically think about the use of chemistry, this is basically to analyze the composition and to be able to discover the percentage of composition. So these three steps will help us do that. If you are having an organic molecule which is, or organic sample which is unknown, say for example I have given you unknown organic sample. I just brought a sample in the test tube and I just gave you this, and I'm asking you, please let me know what all do you have in this, and make sure you tell me the elements that you have in this particular sample, and then tell me the mass percentage of these elements, like how much percent carbon, how much percentage hydrogen, how much percentage nitrogen, etc, etc. Then what do? You have to perform these three steps. Step number 1, you would have to first conduct purification. You take this organic sample, you will conduct purification of this organic sample. And when you conduct purification, what happens? When you conduct purification, you will be having the organic molecules separated. For example, if this is a mixture of 2-3 different organic molecules, you'll be able to separate them. So after purification, after separating the mixture of organic molecules you'll be proceeding forward to the next step, which is qualitative analysis. And what happens in qualitative analysis? Basically, it is nothing but a set of chemical reactions that we conduct in order to identify the composition. Through qualitative analysis, you will be identifying the composition. You'll get to know what exactly is this organic molecule that you're talking about is composed of. If this organic molecule is having carbon or hydrogen or nitrogen or oxygen or something else. And after you get to know the composition, what do? You'll proceed to the next step, which is quantitative analysis. Just identifying the composition is not sufficient. You also need to know the amount of these elements that you have in the given molecule. Amount as in you need to first of all measure the grams, and then you have to convert it into percentage. And when you convert it into percentage, what will you get? Why did you do all of it? The end of the day, by taking this percentage compositions into consideration, by observing the components that you have, you will be able to derive the molecular formula. So the entire idea of having these three steps conducted in lab is to derive the molecular formula. If I give you any random organic molecule, you'll be able to conduct these three steps and you'll be able to tell me the molecular formula. So we'll be understanding these three steps and the procedures involved in these three steps in detail. We'll now talk about purification. In case of this purification, we spoke about purification in early grades itself. Probably in grade 6 or 7 CBSE, we studied purification techniques. And if you're from ICSE, we studied purification techniques in grade 7 or 8 ICSE as well. Like we studied this as separation of substances. And we understood how to separate the simple mixture. Say for example, if I have mixture of rice grains plus stones, we can separate it with the help of hand picking. If I have a mixture of water plus again stones, then I can separate this with the help of filtration. This way, if you are having buttermilk, which is actually a mixture, you will be able to separate the butter from buttermilk with the help of churning. These are the small techniques that we already have learned, and these are nothing but the separation techniques. Even here in purification of organic molecules, we will be adapting the techniques. We will be adapting a few physical techniques to separate, and after that we also will be adapting a few chemical techniques to separate. So purification of organic mixtures basically is nothing but separating the components of a mixture. And how do we separate the components of a mixture? It depends. It depends upon the nature. It depends upon the nature of the components that you have in the mixture. Say for example, if you are having rice pressed stones, you are hand picking. Why are you not hand picking when you have to separate butter from buttermilk? Because according to the properties of the mixture and its components, this method is not feasible. So you have to choose the purification method, or you have to choose the separation method in accordance with the properties of the components of your mixture. If you are having water plus stones, then you have to check the properties of water and stones, assume which will be the best suitable method, and then decide the method implemented. We can't just choose one method and apply it generally to all the mixtures that we have in organic chemistry. So basically the purification techniques are nothing but a kind of separation techniques, and these are applied on organic mixtures to separate the components of the mixtures, and you have to be choosing the purification technique based on the nature of the components that you are having. So in general, when it comes to organic chemistry, we have a few separation techniques which we frequently use because we know the properties of the organic molecules already. We know that organic molecules are covalent molecules because they are covalent. Most of them either are in solid physical state or in liquid physical state. And we know the solubility preferences of covalent molecules. We know that they are soluble in organic molecules. Because we know the properties of these organic molecules already, there are a few methods of purification that we frequently follow, and they also match to the properties of the components very well. So let me first of all list those separation techniques or purification techniques. The very first one is sublimation. Sublimation is one of the purification techniques that we frequently get to observe in case of organic mixtures. And the second one is crystallization. Crystallization is another separation technique. And then the third one is solvent extraction, or you can also call it as differential extraction. And after this, the fourth one is distillation. And then the fifth one is chromatography. So these are the separation techniques that we get to see very frequently in organic molecules. But why do we get to see very frequently? Because organic molecules share a few similar properties. Based out of these properties, the listed separation techniques are very much suitable to them. That's why. And when do we use sublimation? When do we use crystallization? Can we use sublimation anytime that we want for any mixture we have? No. If you're using sublimation, there are some conditions that the mixture needs to be following. If you're using crystallization as a purification technique, your organic mixture should have a few particular properties. We'll study about those conditions and properties in detail when we move to the further pages. But for now, you're talking about the practical chemistry. In practical chemistry, the entire agenda is to be able to sort the mixture that's given to you, purify it, identify its composition by qualitative analysis, identify the mass of the components through quantitative analysis, finally derive the molecular formula. So we are in the first step of this entire process, which is purification techniques. Purification techniques will help you separate the organic mixtures, and you need to adopt a technique based on the properties of the components that you have in the organic mixture. And here are 5 techniques that we will be studying as a part of our syllabus: sublimation, crystallization, solvent or differential extraction, distillation, and chromatography. It's not necessary that every single organic mixture you have can be separated with the help of any of these 5 techniques or all the 5 techniques. It depends upon the components still. Let us understand about these techniques further in detail in the next page. Let's get started with the first technique, which is sublimation. So sublimation we already have studied in earlier grades again as a part of matter and its properties. So sublimation is a physical change or a physical process in which you observe a solid turning into gas directly by absorbing energy from atmosphere, from surroundings. If a solid is getting converted into gaseous physical state directly without any liquid physical state in between, you call the process as sublimation. So the substances which are undergoing sublimation are called as sublimes or sublimable substances. So now the sublimation is something that can happen at room temperature, or this also might need higher temperature. It depends upon the molecule. There are some molecules which sublimate at room temperature. You don't need to give them any additional temperature or any additional energy. But at the same time, there are some molecules which demand high temperature to get sublimed. I'll give you examples for both the cases. You might have seen the naphthalene balls which we use as insect repellents in the cupboards and also in the sinks. These naphthalene balls are made up of a molecule, organic molecule called naphthalene. So this naphthalene is a sublimable material. If you expose naphthalene to atmosphere, you don't even need to heat it. If you expose naphthalene to atmosphere, it will convert itself into gaseous physical state. So naphthalene is an example of a molecule which can undergo sublimation at ordinary conditions. But on the other hand, there's a molecule called as ammonium chloride, NH4Cl. And this ammonium chloride is a white colored solid substance, and this ammonium chloride does not sublime unless you heat it. In order to turn this into its own gaseous physical state, you should be able to heat ammonium chloride. Only at increased temperature you get to see sublimation over here. Similarly, there are so many molecules which demand high temperatures to undergo sublimation. At the same time, there are so many molecules which do not require any high temperature to undergo sublimation. But anyway, sublimation is nothing but a physical change wherein a solid physical state is turning into gaseous physical state as it is without any liquid physical state in between. And now how can we use sublimation as a purification technique for organic mixtures? So when you're talking about the organic mixture, imagine the organic mixture that you're talking about is consisting of a sublimable substance, a sublime and a non-sublime. The organic mixture is consisting of a sublime and a non-sublime. For example, I'm having naphthalene mixed with another organic molecule called A. And this another organic molecule A is perfectly non-sublime. It doesn't turn into gas directly from solid. Now I'm planning to separate this mixture. How can I separate? I look at the properties of the components. I realize that one of the components is sublime and the other one is non-sublime. I have to pick up one such property which is different between both the components that you have in the mixture. And over here, the property that is different between both of them is the capacity of one of the components to sublime and the other component not to sublime. So in case of this kind of mixtures, I can use sublimation as a separation technique. If I heat this mixture, you get to see sublimation of naphthalene happening. You get to see naphthalene turning into vapor physical state and escaping out of the container, and you will be having component A remaining back in the container as it is. So during sublimation, you will be turning one of the components into its own vapor physical state. And now if you wish to extract that, not to lose it permanently, you can conduct the process in a closed container, and as a result of which you will be able to capture the vapors of the sublime, and later you can collect the vapors and solidify them back in order to have a pure form of this sublime achieved. But anyway, sublimation is followed only when one of the components in your organic mixture is a sublime. One of the components in your organic mixture have capacity to undergo sublimation. And sublimation is always not feasible because in organic chemistry we have less molecules which will undergo sublimation at ordinary conditions or at higher conditions. So this is how we can separate the components using the first separation technique, sublimation. Let's talk about the second one, which is crystallization. So the second purification technique in the list that we have made is crystallization. So what exactly is crystallization? First of all, crystal is a type of solid. When I say crystal, I'm just talking about a type of solid which is hard, which is brittle at room temperature, and which also has got a crystal lattice structure wherein there are a few ions arranged in a few particular positions. So now these crystals or crystalline solids are usually formed by ionic molecules. If I have ionic molecules, they usually exist in form of crystals. Other than these ionic molecules, there are a few more polar covalent molecules which have capacity to exist in crystalline form. In organic chemistry, there are a few covalent molecules that can crystallize. So we are making these polar covalent molecules turn into their crystalline physical state. and this process is called crystallization. So crystallization basically is a purification technique. And when can we use crystallization? When the organic molecule has got ionic bond or maybe polar covalent bond, this method is very much suitable. And what happens during crystallization? During crystallization, you first of all would have to take what? You would have to take the organic sample, and organic sample or organic mixture that you are talking about, and you need to observe the composition. If this organic mixture is consisting of the components, out of the components that you have, at least one of them should be soluble in water. One of the components should be water soluble, and one of the components should be able to crystallize or should be able to get converted into crystalline form. So only then you can follow this process of crystallization. And in crystallization, what do is you will be taking organic sample, you will dissolve it into water, and after you dissolve it into water, you first would have to prepare a saturated solution. And after you prepare a saturated solution, what happens? You would have to heat the saturated solution a little. And when you heat saturated solution, the saturated solution will be absorbing this heat energy, as a result of which it will expand a little. Because of its expanding, what happens is there will be more spaces present between the molecules. There will be more spaces created between the solvent molecules. As a result of which, its capacity to accommodate more solute particles will increase. So after you heat the saturated solution, you will be able to add more solute to the saturated solution. Basically, when you say the solution is saturated, there's no scope to add more solute. But because you're heating, the expands, the intermolecular spaces increase, as a result of which you will be able to add more solute. And when you add more solute, the saturated solution becomes supersaturated solution. So you are basically preparing supersaturated solution of the organic sample that you have. And after creating supersaturated solution, which is actually at high temperature, you created this by heating. So supersaturated solution is at high temperature above room conditions. So you would have to cool this supersaturated solution. And when you cool this supersaturated solution, what happens? When you cool this supersaturated solution, all the extra solute that you have added over here, all the extra or more solute that you have added over here will precipitate, or you can also call it as will crystallize. All this extra solute that you have added will crystallize and will settle down at the bottom in form of crystals. So because you are causing the settling down of the crystals of all the extra solute you added, you call this entire process as crystallization. So basically, crystallization is a technique which can be followed when your organic sample is having a polar bond or an ionic bond. And during crystallization, you are crystallizing the soluble part of the organic sample or the soluble molecules of the organic sample. And for that, what would you have to do? You have to take the organic sample, put it into water, dissolve it nicely, make a saturated solution, and then heat the saturated solution so that it expands and it accommodates more solute. And after you accommodate more solute, the solution achieved is called as supersaturated solution, and supersaturated solution is at higher temperature because you had been heating. And now you have to cool the supersaturated solution, and when you're cooling supersaturated solution, all the extra solute that you have added will precipitate in form of crystals, will settle down in form of crystals. And these crystals are the pure form or the purest form rather of the solute that you have added. All the impurities that were present or all the unwanted molecules that were present in your organic sample will be present in liquid physical state itself. So you will be having a residue and you will be having a filtrate. So this filtrate that you have will contain all the impurities. So basically, by precipitating the crystals, you're producing the purest form of the solute, and rest impurities are just remaining in the solution. You will be able to separate the pure form of solute with the help of this method, crystallization. So basically, crystallization is used in case of drugs, medicines and salts when you conduct synthesis reactions in laboratory. This is the second method of purification. Now we are going to talk about the third method, which is differential extraction, which also can be called as solvent extraction. So basically, this third method, which is a solvent or differential extraction, is only applicable when you are talking about a mixture which is consisting of one aqueous medium and one oily medium. As in this solvent extraction is only applicable for organic molecules or organic mixtures in which one of the component is water and the other one is oil. In simple, I can also say that the solvent extraction is a method which is applied for those mixtures which contain two liquids which are insoluble into each other. Two liquids which are insoluble or immiscible into each other. So solvent extraction can be seen when you have oil plus water, where oil is organic molecule and water is inorganic molecule. Similarly, you can also have this when you have two organic liquids which are insoluble into each other, if there is any such. And the solvent extraction is a very simple, very close method to the sedimentation and decantation that we learn. In case of sedimentation and decantation, what do we do? If you are having any such two insoluble forms of matter coexisting in liquid physical state, we first put it into a jar and we let it settle down. All the insoluble particles will settle down at the bottom, and then what we used to do, we simply used to decant the top layer. This was called sedimentation and decantation. Sedimentation decantation is best suited when one of the components is solid. But over here in the mixture that we are talking about, both the components are liquids and both of them are insoluble into each other. So in one similar jar, if you take oil plus water, how does it look like? You will be having water forming the bottom layer because it is more denser, and you will be having oil forming the top layer because it is less denser. And now this oil and water, in order to have them separated, you can decant the jar or you can bend the jar slightly. But if you do so, even the bottom layer would come out because even that is liquid by physical state. So sedimentation and decantation can be used in order to separate two insoluble liquids, but it's not efficient process because both the liquids might get disturbed while you decant. That's why we'll be using the solvent extraction. In this solvent extraction, to separate two insoluble or immiscible liquids, you would be using an instrument. And the instrument that you will be using is called as separation funnel. So separation funnel is a conical instrument which looks like this more or less. You will be having a cone shaped structure, and at the bottom of the structure you will be having a tap which has a control. You can open or you can close the flow according to your requirement, and at the top you have a lid in order to control any other external factors from interfering with the process. In this funnel that you are having, first of all, you would have to be filling the mixture that you are talking about. Right here, the mixture is oil plus water. When you fill the mixture, the bottom layer will be oil layer and the top layer will be, the bottom layer will be water layer and the top layer will be oil layer. In fact, if it is not oil and water, the separation will happen according to denser. More denser component will occupy the bottom, and lighter or less denser component will occupy the top layer. And after adding these components to this separation funnel, you first of all have to mix them thoroughly and then keep them standby. By using a stand also, you can keep them standby in a position without getting disturbed. And after keeping them standby for some long, when you notice that both the layers are actually separated, there is a clear distinction visible between both the layers, then you would have to turn on the tap that you see at the bottom, and you would have to collect the bottom layer into a beaker through the nozzle. And when you're turning on the tap, you need to make sure you have a control over the flow. You need to make sure the flow is drop by drop, or at least slow, to avoid any kind of unexpected interventions over here. So after you collect the first layer, after you collect this bottom layer, once this bottom layer all is extracted into the beaker, you would have to turn off the tap, and then you will be having this particular separation funnel containing the top layer. So basically this is also a decantation, but you're not bending the jar to decant the layers. You are just having a nozzle at the bottom, with the help of which you will be able to extract the bottom layer completely into this beaker or completely into this jar, and you will be able to retain the top layer in the separation funnel. And from separation funnel you can collect the top layer later. So by using this particular instrument called separation funnel, you're just being efficient in separating the layers. You're not using any scientific techniques over here. You're just being a little efficient in separation of the layers. Layers automatically will get separated. You don't need to do anything to have them separated. Just Keep them undisturbed, keep them standby, and they will get separated on their own. In order to extract them, you're using this instrument called separation funnel. This is one of the very effective instruments used to separate two liquids which are immiscible into each other, or two liquids which are insoluble into each other. So these are the three techniques which are commonly used in organic chemistry. Out of these five techniques, sublimation is performed only when one of the compounds or one of the components of your mixtures is sublime. And crystallization is performed when one of the components of your mixture is water soluble. And solvent or differential extraction is performed when you have liquids, two liquids being the components, and these liquids are immiscible into each other. Two immiscible liquids can be separated by solvent extraction.